All right, let's get started on those examples. Make sure you've got this paper before you start, and I'm going to zoom in so it's a little easier to see. There we go. All right, we need to find two statements that are true about consistent and dependent systems of equations. Now, if we look back at our notes, looks like this. Consistent and dependent. We've got two lines that are right on top of each other. We're looking for something with the same slope and same y-intercept. So, are they parallel lines? Nope, not parallel. They're right on top of each other. Does it have exactly one solution? No, has infinite solutions. Lines with the same slope. I mean, yeah, they have the same slope and the same y-intercept, so that's one of them. And they're coincident. Ooh, that's a word I forgot to mention. So coincident means they're on top of each other. They're the same line. The exact same line. Same slope, same y-intercept. So coincident, that's a good word to know. All right, that one wasn't so bad. All right, let's determine the correct statement for the following system of equations. So we want to know, is it consistent, independent, blah, 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 all these big words. Basically, what it's saying is does it cross, these two lines cross once? Are they parallel, never cross at all? Or are they coincident? Are they one on top of each other? Well, to know that, we need to first see if they have the same slope, because if they have the same slope, then it cannot be independent. We can at least knock out one answer, because independent, this means it has one point in common. So let's see, it's easy to find the slope of the first one. Ta-da! It's 5, because we're in slope-intercept form. Okay, well, for the second one, it's a little more difficult. It's almost in standard form, but not quite. So let's get this into standard form. We just need to move this 6 over, so we need to add 6 to both sides. Okay, now it's in standard form. Now I can find the slope. So remember, the slope when you have, let me use a different color. When you have ax plus by equals c, your slope equals negative a over b. So here that's negative a. Well, we have a negative 15. That means do the opposite sign. So we have positive 15 over b, which is 3. And that's 5. Okay, so we have the same slope. So that means it cannot be independent. They've got to have different slopes to be independent. So let's cross out that answer. Can't be that one. Okay, now we got to figure out, oh hey, look, this one doesn't even make sense. If it's inconsistent, it can't be independent. So let's cross out D as well. Because if it's independent, it's got to be consistent. Inconsistent is just inconsistent. It can't be inconsistent and independent, which in a way gives us our answer, but let's double check. So I bet you it's consistent and dependent, because if you're inconsistent, you're neither dependent nor independent. But let's double check. So if it's consistent and dependent, looking back at our notes, so consistent and dependent is when we have two lines that are exactly the same. All right. Well, that would mean we have the same slope, which we got, and the same y-intercept. So the y-intercept on this one is 2. And remember, when you have, again, when we have the standard form, your y-intercept is always, always, always going to equal, let me think about this a moment, it's always going to equal c over b. Yep, that makes sense. So here, that would be c is 6 over b is 3. That equals 2. Look, we have the exact same y-intercept, the exact same slope. That means we have coincident lines. That means it's consistent and dependent. Ta-da! So again, C could not have been the answer because that doesn't even make sense. If you're inconsistent, you're not dependent, you're not independent. So C and D didn't make sense in the first place. All right, let's check out number 3. Oh, number 3. I love number 3. There's one trick to it, but then it's not too bad. We got to find the solution of this system, which means when we say find the solution, Where'd they cross? Hey, look, they cross right there. Ta-da! You're like, wow, Mrs. Stratman, that was so crazy easy. I know. But then you look down and you're like, huh, where are the coordinates? Well, let's see. Oh, gosh, there's no number there. Let's zoom in. Oh, goodness, what am I going to do? I don't know what this number is. Don't freak out. We know this line represents 35. Let's see what line that is. That's 1, 2, 3, 4, 5. So to find out what numbers go on these lines, I take this 35 divided by 5 because we have 1, 2, 3, 4, 5. 35 divided by 5 is 7. So that means each line is going to go up by 7. So 0 to 7, that's 7. 7 plus 7 is 14. Add 7, we got 21. Add 7 is 28, and let's see if we're right. 28 plus 7, that's 35. Okay, so now we know one of our coordinates. We have the same problem here. They didn't label all of their lines because they're jerks. So let's see, we got 10, and it's on line 1, 2, 3, 4, 5. So we take 10 divided by 5. You can use your calculator if you don't know what it is. We get 2, so that means each line goes up by 2. 0 to 2, and then add 2, we get 4. Add 2 is 6. Add 2 is 8, and let's see if we're right. If we add 2, we get 10. Perfect. Now we can see the coordinates of this point. Remember, always do your x first. So we got 28, and our y coordinate is 6. So our answer is 28 and 6. Okay, I'm going to zoom out a little. Whoop. All right, last one. It says solve by graphing these equations, then identify the solution. So reminder, these are in point slope, which if you don't remember, point slope is y minus y1 equals mx minus x1. Okay, so that means we got a slope of 8 for this first one, and our point, remember it's the opposite, it's not -1, our point is 1, comma, and not -7 but +7. So here's how we're going to graph it. We need to put a dot on 1, 7. So we go over 1 up to 7, we put a dot. Then we use our slope to find more points. So that means 8 is really 8 over 1. So we're going to go up 8. 1, 2, 3, 4, 5, 6, 7, 8 over 1. Ta-da! And then we can see if we can fit another point. I don't think we're going to fit another point. We could also go down 8 to the left one. 1, 2, 3, 4, 5, 6, 7. We run off. Okay, so we got at least 2 points. Now we need a straight edge. Ta-da! Where did I put my straight edge? Ah, I have this handy ruler. And let's connect those dots really nicely. Okay. That's pretty good. All right, let's do the other one. I want to use a different color. Okay, so for this one, the slope is 2. And our point, remember, do the opposite, so we got 6, comma, 15. And slope is 2, which is the same as 2 over 1. So first, let's put a dot at 6, comma, 15. So 6, comma, 15, that'd be right up there. Okay. Now we have a slope of 2 over 1. That means we need to go up 2 over 1, but we're going to run off the page. So remember, that's the same as -2 over -1. So why don't we go down 2 to the left one and put a dot. Let's do that again. Down 2 to the left one. 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 Awesome. Let's connect all those beautiful dots. I should make a song because, you know, songs are fun. I can't think of a song that's good for graphing. All right. Now, thank God they did not ask us for the exact point for the solution because it's somewhere here where they cross. I don't know what that is. It just says to identify it with a point. Here's my point. If you're wondering, the x value is somewhere between, if we look, it's between 0 and 1, somewhere between 0 and 1, and our y is somewhere between 4 and 5. But we don't need an exact answer. We graphed it, and that's good enough for that. All right, let's go on to the second page. We got one more on that second page on the back. Okay, we're going to again do some graphing. Now we have two ways we can do this. We can either put this into slope-intercept, or we can look and see how we plot standard. So remember, here are the different ways to do it. So we can either put it into slope-intercept, or remember all these things. You know what? I'm going to just solve each equation for y. That's what I'm going to do. So that means we need to get y by itself. Well, right now we got this 4x hanging out on the same side as 2y. We don't like that, so let's subtract 4x from both sides. So on the left, 4x minus 4x, got nothing. We just get 2y on the left. Be careful, do not combine 8 and negative 4x. Notice the 8 does not have an x. They are not like terms. Do not combine them. So we just end up with negative 4x plus 8. All right, we almost have y by itself. Now what we got to do, we have 2 times y. Well, the inverse operation is division, so let's divide both sides by 2. You got to divide everything by 2. On the left, 2 over 2, we just get 1, so that's just y equals negative 4x over 2. If we pop that in your calculator, you get negative 2x. 8 over 2 is 4. All right, so that means on this one, our slope is negative 2, and our y-intercept is 4. Awesome. All right, let's try this other line. Actually, you know what? Let's go ahead and graph this one. So y-intercept of 4. That means we need to look at our y-axis, put a dot at 4, and then use our slope to find more points. So that means if our slope is negative 2, that's the same as negative 2 over 1. So that means from your dot, go down 2 to the right 1 and put a dot. And do it again. Down 2 to the right 1. Now let's do it one more time. Down 2 to the right 1. That should give us a good straight line. Okay. Yep, that's a good line. All right, don't forget your arrows. Beautiful line. Wonderful. Let's move on to the other one. We're going to do the same thing. We need to get y by itself, so we have negative 8x plus 2y. Let's add 8x to both sides. So on the left, negative 8x plus 8x, that's 0. We just have 2y on the left. Do not combine negative 16 and 8x. They are not like terms. So we end up with 8x minus 16 on the right. All right, we still have this 2 times y. So to get y by itself, we need to divide everything by 2, because that's the inverse operation of multiplication. So 2y over 2 is just y. 8x divided by 2 is 4x. And negative 16 divided by 2 is negative 8. Yay! We have our lovely equation. Now that we have it in our favorite form, our slope-intercept form, that means our slope, that's the number in front of x, our slope is 4, which, remember, that's the same as 4 over 1. And our y-intercept, or b, is negative 8. Fantastic. Let's graph that, see what our solution is. So y-intercept is negative 8, so we go over to our y-axis, put a dot at negative 8. That'd be right there. Use our slope of 4 over 1 to find more points. So go from negative 8, we go up 4. 1, 2, 3, 4 to the right 1. Because remember, it's rise over run. Let's do that again. 1, 2, 3, 4 over 1. One more time. 1, 2, 3, 4 over 1. And then connect your dots. And don't forget your arrows on the end. All right, so remember, our solution is where those 2 lines cross. So hey, look, they cross. Oh, you cannot see that yellow. Well, hopefully you can see. They cross right at this point. So we just need the coordinates of that point. So the x-coordinate is 2. And the y-coordinate, well, we didn't go up or down anything, so the y-coordinate is 0. That's our solution, is 2, 0. So another way you could have written it is like that. There you go. All right, you have some practice. Get to it.